One thing that we like to know when we're dealing with straight lines, oftentimes we like to know what the slope of that line is. When we talk about the slope of a line, that tells us how steep the line is. Nope, there's two E's in steep, pretend. And knowing numerically what that slope is, it can tell us a lot about the line. It can tell us whether our line is going up as we read it from left to right, whether it's falling, whether it is flat, whoops, pretend that's horizontal, whether it just goes straight up and down. It can tell us whether it's rising very slowly, maybe it's rising very quickly, but not completely vertical. Okay. And by understanding what the numerical slope means, it can give us a lot of information about that line. Now, the slope of a line, for whatever reason, is designated by the letter M. We use the letter M to represent the slope. And the slope is always given as a ratio of two values. Okay, very informally, we talk about it being the rise over the run. Now, when we're talking about moving in two dimensions, left and right and up and down, our rise, our vertical movement up and down, has to do with the y-coordinates. Okay, our left and right movement, if we're only sliding left and right, that has to do with our x-coordinates. And anytime we want to find distance in one dimension, if I want to know how far it is between those 2 points, or I want to know how far it is between these 2 points here, okay, the operation we use for that is subtraction. Okay. So if one of my points is called x1, y1, just to be generic, and the other one is called x2, y2, we find the rise by subtracting the y's. It rhymes if that helps. And we find the run by subtracting the x's. Okay. So one way that we can find the slope of a line, if we're given 2 points on our line, then we can find the slope by computing the rise over the run. Now, it doesn't matter which one of these we think of as x1, y1, and which one of them we call x2, y2. We just have to be consistent when we do the arithmetic from top to bottom. So on the top, if I want to find my rise, I know I subtract the y's. Okay. And so maybe I chose to take 5 minus 4. I'm allowed to do that as long as on the bottom, then I start with the 2, and I subtract the negative 3. When I do the arithmetic, 5 minus 4 is 1. 2 minus a negative 3 is a positive 5. And so I would say the slope of that line is 1/5. Now, if at your desk, if you started with the 4 and say, well, I took 4 minus 5. I called this one y2 and this one y1. And so I took 4 minus 5. Okay, that's fine. That's allowed. As long as on the bottom, when you start with your x's, you start with a negative 3. And then you subtract the other one, which is 2. Notice 4 minus 5 is a negative 1. Negative 3 minus 2 more is negative 5. And a negative over a negative still turns into a positive 1/5. It doesn't matter which order you start with when you subtract the y's. But the important thing is that you have to stick with that same order on the bottom when you subtract the x's, and you'll get the same number either way. The slope of that line is 1/5. When if we want to graph that line quickly, I'll make a mess of this slide. Okay, if I want to go through the point 2, 5, which is here, I want to go through the point negative 3, 4, which is here. Okay. Notice that if I connect those dots, Okay. When I read my graph, and I always read my graphs from left to right, just like I read my words on the page from left to right. As I walk from left to right, notice this line is going up. It's not going up very quickly, but it is going up. It's getting higher and higher and higher as I go to the right. Okay. Anytime my slope is a positive number, that indicates to me that my line is going to rise as I read it from left to right. It's going to go up higher and higher and higher. Okay, so this one would have a positive slope, this one would have a positive slope, this one would have a positive slope from my little sketches up above. If my slope is a negative number, that means my line is going to fall as I read it from left to right. It's going to go down the hill. Positive slopes rise from left to right, negative slopes fall. If I have a horizontal line, let's see if I can draw a horizontal line on my tablet. If I want to walk between these 2 points, I don't know what they are. I'm not going to make up numbers for that. If I walk from one point to the other, notice that my rise here is 0. I have not moved any steps up or any steps down, regardless of which one I start with and which one I go to. But I run however far that is, whether that's 1 step or 10 steps or 3.8 steps. Now remember, when we have a fraction, it's okay to have a 0 on top. 0 divided by a number is 0. The slope of any horizontal line is 0. So sometimes when we're reading in our text, it'll talk about a horizontal line. We have to know in our minds that means the slope is a 0. Okay? Or if somebody tells us the slope of our line is 0, we in our minds have to understand that means that that line is horizontal. It runs left and right. It does not rise in any way, shape, or form. In reverse, if I have a vertical line and I want to determine its slope, as I move from one of those points to another, okay, I am rising or falling. Okay, I'm going up or down some number of steps, 1 or 2 or 10. But notice my run, my left and right movement is 0. It is not okay to have 0 on the bottom of a fraction, which means the slope of this line is undefined. Okay. Vertical lines have slopes that are undefined. Now, some students, and back a long time ago, we occasionally used a phrase called no slope. Okay, please do not use that phrase at all for me in your work. Okay, tell me that the slope is 0 if it's horizontal. Tell me it's undefined if it's vertical, because some of you will use no slope for this one, and some of you will use no slope for that one. And so I don't want that phrase even being in our vocabulary. Okay, tell me that the slope is 0 on a horizontal line, that it's undefined for a vertical line.